Welcome to The Explainer. Today, we're diving into a massive shift happening right now in the tech world. For the longest time, building interactive, high-performance 3D environments felt, kind of like a dark art, right? It was locked behind super complex game engines and required these massive development teams. But things are changing fast. Today, we're looking at how some incredibly powerful new technologies are completely tearing down those barriers to 3D creation. We're going to trace this really cool through line, starting from the absolute lowest levels of graphics code and follow it all the way into a primary school classroom. Let's get into it.
Okay, here's our roadmap for today. First, the power of custom 3D. Second, enter Flutter GPU. Third, building with Flutter Scene. Fourth, 3D gaming and education. Fifth, empowering teachers with MIRNA. And finally, number 6, the future of 3D. Section 1. The power of custom 3D. Why standard fails. To really grasp how 3D tech is changing the real world today, we first need to understand the foundational tech and exactly why the old way of doing things was basically holding creators back. So let me ask you this. Who actually controls the 3D rendering in the apps you use every day? Historically, this has been a huge headache. App developers were essentially locked out of the engine room. They had to rely on these generic, off-the-shelf black box renderers. And if you wanted to do something highly specialized, like, say, rendering 3D slices of a 4D space or projecting non-Euclidean spaces, well, you're pretty much out of luck. It was a totally frustrating uphill battle, like trying to force a square peg into a round hole using tools that just weren't built for you.
This brings us to a really crucial point, perfectly captured by Brandon Derazier over on the Flutter blog. He argues that generic and high performance are actually antithetical goals. Think about it. Generic 3D renderers try to solve every use case for everyone, and the result? They're adequate at everything, sure, but excellent at absolutely nothing. Specializing for one use case in a generic engine usually means dragging down the performance of another. Custom renders, on the flip side, let you be specialized, high performance, and perfectly tailored to exactly what your app needs.
Section 2. Enter Flutter GPU, controlling the engine. If generic renderers are the root of the problem, we need a solution that hands control right back to the creators. And that brings us to our first major technical breakthrough.
Enter Flutter GPU. So what is this? It's a built-in, incredibly low-level graphics API directly inside the Flutter framework. What makes this a total game changer is that it allows developers to build entirely custom renderers using just standard Dart code and GLSL shaders. And shaders are essentially just mini programs telling your graphics card exactly what to do. The best part? There is absolutely zero native platform code required. It's currently running on the Impeller rendering backend, which is custom built for Flutter. This isn't just a minor update, folks. This is literally handing developers the keys to the engine room.
Think of this as the ultimate builder's journey. And getting started is surprisingly straightforward. To draw a basic shape from scratch, like say your very first 3D triangle, you just add the Flutter GPU SDK, right? And import some simple vertex and fragment shaders to tell the computer where the points are and what color they need to be, and then you just bind your pipeline to draw it to the screen. Bam, you are now communicating directly with the GPU. But it doesn't stop there. Let's look at how this foundation scales up into something even wilder.
Section 3. Building with Flutter Scene. High-level 3D tools. Because, let's be honest, while drawing a single triangle from scratch is super cool for graphics engineers, what about developers who want to build entire 3D worlds without writing low-level shader code every single time?
That is exactly where Flutter Scene comes in. It's a brand new 3D scene graph package powered entirely by Flutter GPU. And this brilliantly illustrates what happens when developers use low-level control to build amazing high-level tools. Flutter Scene comes packed with physically based materials, so light reacts just like it does in the real world. It supports 3D Gaussian splatting, which is this cutting-edge way to drop in photorealistic real-world volumetric captures. It's got a full post-processing stack for cinematic effects, particle systems, and this is the crazy part. You can actually embed fully interactive Flutter widgets directly onto 3D surfaces in your scene. It's mind-blowing.
Section 4. 3D gaming in education, real-world solutions. But giving developers the keys to the 3D engine room is really only half the story. The ultimate question is, what actually happens when we take these powerful 3D environments and use them to solve real-world human problems? To answer that, we need to look at a very specific, very real challenge. During and after the COVID-19 pandemic, the rapid shift to distance learning left a lot of students behind. Specifically, primary school students who are categorized as slow learners found it incredibly tough to adjust to standard digital platforms.
They lost that hands-on, engaging, personalized attention of the physical classroom, and staring at text-heavy screens simply wasn't cutting it for them.
To tackle this head-on, researchers developed MIRNA. So what is MIRNA? It's an assistive 3D instructional game designed specifically for these primary school slow learners, focusing on Arabic, English, and math. But what makes MIRNA so innovative isn't just the fact that it's in 3D. It's that it categorizes students based entirely on their actual academic performance rather than their age. It automatically adjusts to their specific limitations and learning pace.
Section 5. Empowering Teachers with MIRNA. MIRNA in action. Now, this technology is obviously fantastic for the students, but it begs the question, who is actually creating the content inside this game? You'd probably think you need a whole team of those hardcore graphics developers we talked about earlier, right?
Well, actually, no, and this is where the democratization of 3D truly comes full circle. MIRNA features an interface designed specifically for teachers who are complete non-programmers. A teacher can just jump in, insert 3D models, create drag-and-drop spelling games, or set up multiple-choice math puzzles with animated visuals and sound effects, all without writing a single line of code. Think about that for a second. We have gone all the way from hardcore developers writing GLSL shaders to primary school teachers simply dragging and dropping 3D assets to build custom lessons for their kids.
Now, what's really interesting about this adaptive logic flow we're looking at here is how dynamic it is. When a student tries to spell a word or answer a math question, the game doesn't just give them a pass or fail. If they get it wrong, the game provides visual and auditory hints and lets them try again. If they nail it, it dynamically promotes them to a harder level. But if they fail multiple attempts, it gently shows the correct answer and scales back the difficulty. The 3D environment is literally adapting to the child in real time. But the real test is, does a system like this actually work in practice? Well, researchers took MIRNA to 16 elementary school teachers in Jordan, none of whom were programmers, remember? After training them and having them design their very own 3D educational content, the results were overwhelmingly positive. Out of a 5-point scale, teacher satisfaction hit a massive 4.7. Their intention to actually use this in future classes, a 4.6. This is concrete proof that high-end 3D tech, when it's packaged correctly, becomes a highly effective, incredibly accessible tool for everyday educators. The tech genuinely works.
Section 6. The future of 3D? No more barriers. So, zooming out, what does this entire journey, from a low-level Flutter API to a primary school in Jordan, tell us about where we're heading next?
It tells us that the walls are finally coming down. As Brandon Derassier so enthusiastically noted when introducing Flutter GPU, we are entering a brand new chapter, one where you collectively take control over the rendering. This whole shift isn't just about graphics engineers getting shinier tools. It's about what those engineers build with those tools, things like Flutter Scene, and eventually life-changing platforms like MIRNA that end up empowering absolutely everyone else.
The power to build, shape, and utilize fully interactive 3D worlds is no longer locked away in some corporate vault. It's right there in the hands of the developer coding in Dart, and it's right there in the hands of the primary school teacher designing a spelling game. So, I want to leave you with this thought. If the technical barriers to building and using interactive 3D worlds are finally gone, what will you create next? Thank you so much for joining me for this explainer, and I seriously cannot wait to see what you build.